Hi, in this video I'm going to go through question 3 on Math 2008. So here we're given a graph of y equal to f of x, and they tell us that on these three axes we have y equal to f of minus x, f of x minus 1, and also minus f of x. And you have to say which of these functions correspond to which of the graphs. Okay, so we know that f of minus x is just a reflection in the y-axis, and f of x minus 1, that's a translation by 1 to the right, and minus f of x is a reflection in the x-axis. So if this is our original function, then a reflection in the y-axis, that looks like b to me, because this root here has gone over to the negative side. So b shows the graph of y equal to f of minus x. And for a translation, that seems to be c. And so finally, the reflection in the x-axis is a. Okay, now for part 2, they want us to sketch 2 to the minus x squared and 2 to the 2x minus x squared on the same axes. Okay, so let's do 2 to the minus x squared. So if we think about what 2 to the minus x looks like, so it'll be a bit like this blue curve here. If I call this point here 1, and if I call this point 1 as well, then if we think about the graphs of x and x squared, they look a bit like this, right? So between 0 and 1, x squared is less than x, and then they cross when x is 1, and then x squared is larger. So if between 0 and 1, x squared is less than x, then we also have that between 0 and 1, minus x squared is larger than minus x, and so 2 to the minus x squared is going to be larger than 2 to the minus x. So between 0 and 1 in our graph here, we'll have that 2 to the minus x squared lies above the 2 to the minus x graph. And then they're equal when x is 1, so these two curves will meet when x is 1. And then when x is greater than 1, x squared is greater than x. And so we also have minus x squared is less than minus x. So 2 to the minus x squared is less than 2 to the minus x. And so past 1, our 2 to the minus x squared graph is going to lie beneath the 2 to the minus x1. So what we're left with is a graph like this. And remember, x squared is symmetrical about the y-axis, and so 2 to the minus x squared, this is going to be symmetrical about the y-axis too. So we get that this 2 to the minus x squared graph is going to look like this. Okay, so now what about 2 to the 2x minus x squared? So we can't translate by 2x, so we're going to have to do something else first to make this into a transformation that we recognize. So a standard trick is to just complete the square on this indices. So if we complete the square on the 2x minus x squared, we have this. And so this is like our 2 to the minus x graph, but translated by 1. And for this plus 1 on the end, well, this is like saying 2 to the minus x minus 1 squared times 2 to the 1, which is just 2. So we see that this gives us a stretch by 2 in the y direction. So overall, the transformation that we have is a translation by 1 in the positive x direction and a stretch by 2 in the y direction. So that's going to give us a graph that looks like this. And the question also asks us to label any stationary points. So we can see that the only stationary points are going to be here on this 2 to the minus x squared graph. So this point is 0, 1. And for the 2 to the 2x minus x squared graph, then our stationary point is going to be here. And because we know that we got this graph by translating 1 to the right, so the x value of this point is 1, and we've stretched by 2 in the y direction, so now this is twice as tall as this one, so this y value is going to be 2. and so the stationary point of this is 1, 2. Okay, now for part 3, we're told that c is a real number, and we define this integral IC. And they want us to state the value of c for which IC is the largest, and also to explain how we got there. Okay, so let's think about the graph of 2 to the minus x minus c squared. So that's going to be like the 2 to the minus x squared graph, but it's going to be translated by c. So for example, if c were positive, then it would be translated by some value c to the right. Or if it were negative, then this graph will be somewhere over here. And this integral is just the area under this curve between 0 and 1. So it will be this area. So what they're asking for is, where do I move this graph? Where do I translate it so that between 0 and 1, the area under the curve is going to be largest? Well, if we just think about the shape of this curve for a second and ignore the axes, so we can see that we're going to get the greatest area if we take the area around this middle bit, because this is where the curve is highest. So if I take any interval of length 1, then the area under the curve during that interval is when the highest point of the curve coincides with the middle of the interval, because then that's where the curve is highest, and so we're going to get the biggest area underneath the curve there. So if we moved our curve so that this interval over which there is the largest area matches up to the interval that we're integrating over, then that's going to maximize our integral. So we're integrating between 0 and 1, so we want the middle of our curve to match with the middle of the interval 0, 1. So we're going to have c equal to 0.5 or a half. And an example for what you might write for the explain your reasoning bit, we can say something like this. So 2 to the minus x minus c squared is 2 to the minus x squared translated, and 2 to the minus x squared is symmetrical and decreasing on either side of its maximum. And so we maximize the area by taking the area around its maximum. And so because the maximum of 2 to the minus x minus c squared is at x equals to c, then we just put c in the middle of the interval we're integrating over, and that gives us c equals to a half.